Hey everybody, welcome to 5.5 using congruent triangles. We've talked a lot about congruent statements with the ASA, the AAS, the SAS, SSS, all that, hypotenuse leg. Okay, today what we're going to be doing is using those statements to prove congruent parts together, which leads us to our definition, CPCTC. Okay, sounds fun. CPCTC, CPCTC. Okay, a lot of C's. It says, is an abbreviation for the phrase corresponding parts of congruent triangles are congruent. Okay, what this says is that it can be used as a justification in a proof after, okay, and that is very, very key, after you have proven two triangles congruent. So you can only use this at the very end after you have used the congruence theorems, the AAS, ASA, SAS, SSS, and hypotenuse leg. So when you use this, it can only be used in a two-column proof at the very end. Okay, and we're going to go through a couple of these. So again, you use this at the very end. So once you prove the triangles, then you can use it. Okay. So you don't have to write this down. It says the landscape architect sets up the triangles shown in the figure to find the distance of JK across the pond. So we're trying to find JK. What is JK? Well, using that drawing, what information do we know? Well, the very first thing is I know that JL is going to be congruent to LN. Why do I know that? Well, because 19 feet is equal to 19 feet. So they have to be congruent. So JL is congruent to LN. Okay, on the other side, if you look at this, ML is congruent to LK. Okay, so L is almost the midpoint of JN, and L is the midpoint of MK. So now I have these two opposite sides. Okay, also congruent. I have two triangles, I have two opposite sides, but that does not give me enough information. How can I find that first to prove these two triangles are congruent? Because that's what I have to do first. Well, I also know, if you remember, vertical angles. Those vertical angles, meaning those two angles are congruent. Okay, what this tells me is I have two sides congruent with the included angle. Okay, I've proven those two triangles by which property? Side angle side. Yep, you got it. So now because of this, though I have the side angle side congruence theorem, I know that JK, okay, this side is going to be equal to MN because of CPCTC. So what is JK? That is going to be 41 feet. Okay, if I wrote this as a two-column proof, okay, I know that JL is going to be congruent to LN. How do I know that? Well, it did give us that, so that was given. Okay, I also knew that ML was congruent to LK. How did I know that? Also given. Then that piece of information that we had, meaning angle JLK, is going to be congruent to angle MLN. And the reason we know that is vertical angles. Okay, that theorem. Then we put those together and we said that triangle MLN, and you have to be careful with these sides, remember, is going to be congruent to triangle KLJ by our side angle side theorem. So because I have put those with the given statements, vertical angles, I've now proven that the SAS theorem is possible. Okay, I know what MN is. I know MN is congruent to, congruent to KJ. And the reason because of that is going to be my CPCTC. Okay, so in this statement, I don't need to put a two-column proof, but I wanted to show you what that looks like as a two-column proof. You use CP/CTC at the very end of your side angle side theorem. Be able to back things up with evidence. All right, so I want you to draw and try this. Okay, in your head, you may already know what it is because it looks like that, but I want you to be thinking, why do you know the answer? Why? Okay, give it a shot. All right, so the very first thing is remember to be able to explain your answer. What is AB? Well, because I know that this side right here is going to be congruent to this side right here, okay, I know that those two are congruent. I also know that this side is congruent to this side. Why? Because they are both 15 miles. Okay, so what that tells me is I have two pairs of sides that are congruent. But I need to have another piece of information to be able to prove those two triangles are congruent. Well, because of that wonderful theorem of vertical angles, I can say that those two angles are congruent. Now, because I have two sides with the included side, I can say that those two triangles are absolutely congruent. Why? Because of the side angle side congruence theorem. All right. So now that I have proven those angles congruent, or sorry, those triangles congruent, now I can figure out what AB is. Well, because of CP/CTC, that third side, that AB, has to equal 18 miles. It has to be 18 miles. The reason, because I've proven those two triangles are congruent. This is my last side here of 18 miles. That means AB has to be 18 miles. All right, so you can use those congruence properties first, and then you look at your CP/CTC. So you have to do that one first, then CP/CTC. Okay, so here's a two-column proof that I'm going to make. It is given that PR bisects angle QPS and angle QRS. I need to prove that PQ is congruent to PS. Okay, I'm going to start with my congruent theorem. Okay, and on the left side, okay, I have that wonderful information from the very start. I have PR bisects angle QPS and QRS. And I use my steps as one because the reason I want to keep them organized. Okay, so I know that PR bisects QPS on the left side is given on that right side. So those two are matched up together. Okay, my next piece of information. Well, if I look at, again, try to split that shape into two triangles. So if I look at this, I need to be able to say, well, this side has to be congruent to itself. Okay, and I know that PR is going to be congruent to RP. Why? Well, I know that is because of the reflexive property. The next thing that we can definitely say is we can definitely say that a couple angles are going to be congruent. Okay, remember that given statement on number 1? Okay, it tells us that PR bisects two angles. Well, that also tells me that because of that, that makes QPS, okay, because PR is a bisector of QPS, that tells me QPR is going to be congruent to RPS, and that QRP is congruent to SRP. Okay, so I can say that. And the reason why is because of our angle bisector. So my number 3 is going to be angle QRP is going to be congruent to angle SRP. And angle, and I can say this in the exact same step because I'm using the exact same reasoning behind it, angle QPR, and that is a Q, is going to be congruent to angle SPR. And the reason behind both of those, that is the angle bisector theorem. Okay, remember that angle bisector theorem, meaning if it bisects an angle, it cuts it right in half. Okay, so my angle bisector theorem. They are angle bisectors. Well, if you look at these two shapes now, these two triangles, if we had to basically divide them into two triangles, this being the top half, this being the bottom half, you will notice that we have a side and we have two angles, and that side is specific because it is included. So my next piece is going to say that these two triangles are congruent. Okay, triangle PQR is going to be congruent to triangle PSR. And the reason behind that is going to be our angle side angle theorem. Okay, so now we have our angle side angle theorem. We now know that these two triangles are congruent. Because we know these triangles are congruent, we can safely say that the fifth one is going to be PQ is going to be congruent to PS because of my CPCTC. CPCTC. Okay, so because of CPCTC, I can say that at the very end. Again, it will always come after you have proved those two triangles congruent. It has to come after. When does it come? After. CPCTC comes after you have proven the triangles congruent. Okay, I'm going to have you do your own two-column proof, and I want to see if you can get this. So here's the shape. Here's the information. Given J is the midpoint of KM and NL, prove that KL is going to be parallel, that sign parallel, not congruent, parallel to MN. Okay, MN. Give this one a shot. All right, so we're going to try this one. Okay, this is a shape. Of course it's a shape, but we're going to be using a lot of different theorems. So try to stay with me here. Okay, I have my two-column proof. Okay, so now, what information do I know? I know that J is the midpoint of KM and NL. Okay, so in this, I'm going to write that. That's my very first step. So 1, J is the midpoint of KM and NL. That was given. I need to be able to put that in there because that's the piece of information I was given. Okay, what does that information tell me? Well, second step is going to be, well, because of that, I'm going to say KJ is going to be congruent to MJ, Michael Jordan, KJ, congruent to Michael Jordan, what? Okay, and NJ, not NJ, NJ is going to be congruent to LJ. NJ, NJ, little Espanol. Okay, anyways, so the reasoning behind that is going to be, well, how do I know that? I know J is the midpoint, which tells me the definition of my midpoint is going to be that it's in the middle of two of the overall segment. So it's got to be in the middle, which means it splits it up into two even sections. So definition of midpoint. Done. Number 3. We're just moving right along. Number 3. Okay? I now know, what else do I know? According to this piece of information. Well, looking at this shape, so I know that. I apologize. I need to put my markings on here, because if I don't put markings on, okay, it's a little harder to visualize. Okay, I now know, well, I have those two shapes. Well, I know that this is going to be congruent to this. So what two angles are those going to be? Well, I know that LKJ, angle LKJ is going to be congruent to NMJ. How do I know that? Well, those are vertical angles. I know that those are vertical angles. Now this tells me, I could also put that KJN is going to be congruent to MJL. Okay, those are also congruent, but I'm focused on those two sides. So comparing KL and MN. If I put the other two angles, which is fine, we can put that in our statement, but that would focus on KN and LM. So those are my two vertical angles, okay, which leads me to my next statement, number 4. I now have two congruent sides with the included angle. That tells me that triangle KJL is going to be congruent to triangle MJN. Again, two congruent sides with the included angle where those two sides come together, known as my side angle side theorem. Okay, side angle side theorem. Now, what information does that tell me? Okay, again, I'm moving on to get to where KL and NM are parallel. Where they are parallel. How could I say that those are parallel? Well, if you remember, okay, I'm going to start focusing on your parallel theorems, your converses. Remember your converses? Okay, being the alternate interior, alternate exterior, same side interior, those corresponding angles. I'm going to be pushing for that. So now, how could I use that information with the given information and the evidence I have behind it to support that? Well, number 5, that leads me to believe that LKJ, this angle right here, is going to be congruent to NMJ, this angle right there, NMJ and LKJ. How do I know that? Remember, that's where your CPCTC comes into play. Okay, so at the very end, we do have CPCTC. Now, the question is, though, does that give me my answer to this problem? Was my last step wanting to be angle LKJ is congruent to angle NMJ? No, it's not. I need to know that KL, this side, is congruent to MN, which is that side. Okay, I can't use CPCTC to do that because I'm not looking for a congruent statement. But if I know those two angles are congruent, I now can use my converse statements. So number 6 is going to be KL is going to be parallel to MN because of the converse alternate interior angles. Okay, so be careful there. You need to bring in that previous information from other chapters to form your conclusion statement. Okay, so because of this information, we can conclude that KL is going to be parallel to MN. If it gives you this statement, the given and the prove, you will be able to prove this. You just need to find a way to do it. Okay, if you have questions on this or this lost you in any way, make sure to ask. Make sure to ask. Okay. come in tomorrow when you get your homework and say, Mr. Sheeman, I just didn't get it. Okay, make sure you ask me tomorrow. Other than that, that's all I have. Have a great day. I will see you tomorrow. See ya!